In this video, I want to show you how to hook up your multimeter to measure current. To measure current, you'll hook up the multimeter differently than when you measured voltage. When you measured voltage, you use the multimeter leads to measure across components. So you had a resistor circuit and you would measure across each resistor. You could think about the multimeter in that case as in parallel with the component that you were measuring. However, when you're measuring current, you want to measure it in series with the circuit components. It needs to be part of the circuit. You can think about the definition of voltage. Voltage is a potential difference between the electron supply and electron shortage. So you're measuring across something to get that difference. When you're measuring current, you're measuring the amount of charge that passes per time. So you're trying to measure how many electrons pass over a certain amount of time. You need to have those electrons passing through the multimeter so that it can measure the number per time. In order to set up your multimeter to measure current, I'm going to use the small gear motor that was included in your kit and the two alligator clips that have the leads that can plug into the breadboard. We're also going to use your Arduino and the breadboard. We're using the Arduino as a voltage source and the breadboard to build our circuit on. I'll start by plugging in the alligator clips into the breadboard. You'll plug the red lead into the 5 volts that are supplied to the breadboard and the black lead to ground. You can plug these on either side of the breadboard, just wherever it makes sense for you to build your circuit more easily. I'm going to plug the black lead into the ground on the opposite side so that I have a little bit more space building my circuit. Now I'm going to show you just a complete circuit before connecting the multimeter. Once I connect my alligator clips to the red and black lead of my motor starts spinning. You can see the gears turning and the shaft turning as well. This is a complete circuit. You have 5 volts powering the circuit. The current's going through the red alligator clip, through the motor, through the black clip to ground. So the current has a path to go from positive to negative. Now what I want to do is I want to incorporate the multimeter into the circuit so that I can measure what is the current value. So I'm going to disconnect the red alligator clip, and now you can see my circuit is open. I have my red alligator clip connected to the 5 volts, but it's not connected to anything. That circuit is broken. The rest of the circuit is connected to ground, but because these are not making contact, we have an open circuit. We're going to incorporate the multimeter in between this open circuit. Take the red lead of your multimeter and connect it to the red alligator clip. Now current can pass from the red alligator clip through the red lead of the multimeter into the multimeter. And now the black lead needs to be connected to the circuit so that it has a path to flow through the motor and through to the ground. So take your black lead and connect it to the motor. Now we have a complete circuit. The motor's not turning because our multimeter is not on, and therefore we're not allowing the flow. It's as if this is a switch. Once we turn this on, the circuit will be complete. But you can see how the different components are connected. We have our 5 volt power supply. Current can pass through our red lead, our red alligator clip, through the red lead of the multimeter, into the multimeter, through the black lead of the multimeter, to the motor, and then to the black lead of the alligator clip to ground, so that it has that path that it can flow. Now I'm going to turn my multimeter to the DC milliamps because I have my red lead plugged into the multi-jack. And now you can see the motor started to spin and I'm getting a value for current. It's roughly 31 milliamps. The number is kind of wavering. Another thing that you can do is you could move it onto the DC 10 amps. That might give you a more stable value. The DC 10 amps is not connected to the fuse in the multimeter. Usually the DC 10 amp section is used to measure larger current values. But let's see what happens when we move it over. So I'm going to take the red lead and plug it into the DC amps. Notice my motor started turning. That's because it's not being controlled by that fuse that's in the multimeter. I can turn it over to DC 10 amps, and now I'm getting a little more stable reading of 31 milliamps. Notice it doesn't automatically move it to milliamps because it's expecting higher current values. Be careful when setting up your multimeter to measure current It's very likely that you can set it up incorrectly and blow a fuse. If you blow a fuse, don't stress too much about that. We have included an extra fuse in everyone's kits. You can follow the presentation on troubleshooting your multimeter found on the schedule and downloads page for our course in order to replace the fuse if you were to blow it. If you blow the fuse, you'll just be reading incoherent numbers, all zeros, or you might get an L that comes on the screen, and you'll know that you need to replace the fuse. You can also reference that presentation to look at your fuse to see if it could be blown.